We will now solve problems using the concepts of force of friction. Let's start with this problem. When a horizontal force of 300 Newton is applied to a 75 kilogram crate, it slides on a level floor opposed by a force of kinetic friction of 95 Newton. What is the acceleration of the crate? What is the coefficient of kinetic friction between the crate and the floor? Well, let's picture the problem. Here is the crate that is sitting on the floor, and the mass of the crate is 75 kilogram. The weight of the crate mg is m times g, that is mass 75 kilogram times 9.8 meter per second squared, is 735 Newton, which will be acting vertically down. The normal force on the crate Fn, tell me, what is the normal force on the crate? The normal force will be opposite to this. So that will be the normal force, and that will be equal to 735 Newton. Alright, what are the other forces acting on the crate? So Fn equal to 735 Newton. A force F equal to 300 Newton is applied to the right. There you have a force of 300 Newton applied to the right. And now you have a frictional force between the crate and the floor. How much is the frictional force? That is 95 Newton. So since the crate is moving, the force of friction is kinetic, and it is given as 95 Newton. The force of kinetic friction is 95 Newton, and that will be opposing motion. Therefore, what is the net force on the crate? The applied force is 300 Newton. The force of kinetic friction opposing that is 95 Newton. Therefore, the net force is the applied force minus the force of kinetic friction, and that is 205 Newton. And you can see the vertical forces will not play a role in the motion here because they cancel each other. Okay, this net force produces an acceleration on this mass of 75 kilogram. So we have F net equal to ma. 205 Newton is the net force. That net force equal to 75 kilogram times A, and solve for A. That gives you A equal to 2.73 meter per second square. Well, we found the acceleration. What is the next part we need to do? What is the coefficient of kinetic friction? Well, if you remember the definition of coefficient of friction, it is the frictional force divided by the normal force. Well, the force of kinetic friction is 95 Newton. The normal force is 735 Newton. And so we can now write Fk equal to mu k Fn. I have inadvertently used the uppercase F here. It's supposed to be the lowercase f. So the force of kinetic friction, lowercase fk. So make that change there. The force of kinetic friction is mu k times the normal force. That is mu k times mg. Therefore, mu k equal to Fk divided by mg, and Fk is 95 Newton, mg is 735 Newton, and that is 0.13. So you can see these kind of problems are fairly simple once you can picture it and put the forces in the right place. Okay, let's look at another problem. A stalled 1500 kilogram automobile is pushed towards a gas station by a man and a woman. The man applies a horizontal force of 335 Newton and the woman applies a horizontal force of 220 Newton. There is no gender discrimination here. This just so happened. If there is an effective frictional force of 400 Newton on the car as it moves, what is its acceleration? Well, again, you can figure out the net force. There is a total force. What is the total applied force? 335 Newton that is applied by the man plus 220 Newton that is applied by the woman. So the total force minus the effective frictional force, that is 400 Newton, that will be the net force. And the acceleration on the car is produced by that net force. Is that right? Okay. Now, once the car is moving, what combined force will keep it moving uniformly? Now, once the car is moving, to keep it moving uniformly, you need only overcome the friction. That means there is no need for an excess force. There will be no net force on the car. All right, let's set it up. The total applied force is 335 Newton plus 220 Newton, that is 555 Newton. And the frictional force is 400 Newton. Therefore, the net force on the car now is 155 Newton. It is this net force that produces an acceleration on the car. What is the mass of the car? The mass of the car is 1500 kilogram. So the acceleration therefore is net force divided by the mass, that is 155 Newton divided by 1500 kilogram, that is 0.103 meter per second square. Alright, can you answer the second part without my help? Actually, I answered that for you. Once the car is moving, what force will keep it moving uniformly? So, once the car begins to move, to keep it moving uniformly, you need only overcome the friction, which is 400 Newton. That means the combined force need only be equal to that 400 Newton. Is that right? Yes. So once the car is in motion, they don't need to produce an acceleration on it. They need only keep it moving steadily. And in order to keep it moving steadily, the forces must be balanced. And the combined force therefore must be equal and opposite to the frictional force. That is, they need only apply a combined force of 400 Newton. So probably the man can keep on applying that 335 Newton and the woman can give a hand by applying about 65 Newton. Is that right? Okay, simple problem. Let's look at another problem. A 5 kilogram wooden block is placed on an adjustable wooden inclined plane. What is the angle of inclination above which the block will start to slide down the plane? You remember in the previous lecture I told you, at a particular angle, the mg sine theta down the plane will be exactly balancing the frictional force mu mg cos theta. Now, if the angle is greater than that, then it will begin to slide down. So you need to find that critical angle. Well, that angle, if you remember, is such that the coefficient of friction will be equal to tangent of the angle theta. So what is the angle of inclination above which the block will begin to slide down? At what angle of incline will the block then slide down the plane at a constant speed? Coefficient of static friction between the surfaces is 0.58 and the coefficient of kinetic friction mu k equal to 0.4. Well, if you understand the concept, this problem is very simple, because when the object just begins to slide down, the angle will be such that tan theta equal to mu s. And now, once the object begins to slide down, to keep it moving, you can actually decrease the angle, because you don't need the same amount of force to keep it moving. And so the angle at which you can keep it moving with a constant speed will be such that the tangent of that angle will then be the coefficient of kinetic friction. Well, let's put that down. Here is the block placed on the inclined plane. The mass of the block is 5 kilograms, and therefore its weight will be 5 times 9.8, that is 49 Newton acting vertically down. The component of the weight down the plane is 49 sine theta. Is that right? 49 sine theta. We don't know the angle. Now, the component of the weight pressing on the incline, the normal force, is 49 cos theta. The normal force Fn balances this force. So Fn is the same, which is 49 cos theta. And now, what is the frictional force acting up the plane? Do you remember that force? Fs equal to mu s mg cos theta. In other words, the force of static friction is mu s times Fn, mu s times 49 cos theta. So that is the normal force, Fn equal to 49 cos theta. Now, just before the block begins to slide down, the force of static friction Fs acting up will be Fs equal to mu s times 49 cos theta. You see that? This is the maximum frictional force. That means just when the block is ready to move down, this will be the force of limiting friction, the static friction, and that will be mu s times 49 cos theta. Well, at the instant when the block begins to slide, the downward force pulling the block down, which is 49 sine theta, is balanced exactly by the force of static friction acting up the plane, that is mu s 49 cos theta. There you are. We have actually done this before. So 49 sine theta equal to mu s 49 cos theta. Therefore, mu s equal to sine theta divided by cos theta equal to tan theta. In fact, I actually repeated that whole process for you to solve this problem. You can actually start here and say, when the block begins to slide down, the angle theta is such that tan theta equal to coefficient of static friction. That would be enough. And therefore, 0.58 equal to tan theta, or theta equal to tan inverse of 0.58, that will be 30 degrees. And now, the B part, when